This week, we're going to talk about something entirely different. Instead of talking about a data structure that seems really, really useful for common sets of data, we're going to talk about a data structure that's somewhat specialized, but it's going to have huge applications when we begin starting to talk about graphs. Specifically, we're going to talk about the idea of disjoint sets. A disjoint set is going to be a series of sets which are disjoint from one another, but every single element within a set is considered to be equivalent within that set. Let's take a look at an example to see what that means. So here are 4 disjoint sets. We have one set that contains the elements 2, 5, 9, another set that contains the element 7, another set with the elements 0, 1, 4, and 8, and a final set with the element 3 and 6. When we consider each of these sets, we consider every element inside of a set to be absolutely equivalent. If you're familiar with mathematics, this is something saying that these two elements are in an equivalence relationship with one another. As far as we're concerned, 2, 5, and 9 are completely indistinguishable. We can do operations on the disjoint set like the find operation. The find of 4 operation is going to find the set identity for the set that contains the element 4. So we can choose any single element to be the set identity or call it something completely different. Just to be really, really clear, I'm just going to always use the first element as my list to be the identity element for that set. So what this means is if we look at this set right here of 2, 5, and 9, the identity element for this set is 2. The identity element for this set here is 7. The identity element for the set 0, 1, 4, and 8 is 0. The identity element for the set 3 and 6 is 3. The big idea is we need to make sure the identity element for every single set is unique so that we can differentiate a set from one another, but we can now know that the identity of every single element within a given set is going to be the exact same thing. So when we find the element 4, what we're going to return is we're going to return the set identity for that element. So here, finding 4, we say the set identity of that element is 0. Likewise, one operation that we need to ensure is consistent is we need to ensure that find of 4 has the exact same value as find of 8. Because find of 4 and find of 8 both need to return the same set identity because both 4 and 8 are in the same set. In this example, we have 0 as a set identity, so both find of 4 and find of 8 are both going to return 0. 0 is equal to 0. So we see that by choosing a set identity, we can ensure when we do a find that we can find whether or not 2 elements are in the same set. The other operation that we're going to care about is not only do we need to find, but we may need to actually union 2 sets together. Once we add an element to a set, we can never separate it again. So by unioning 2 sets together, what we're doing is we are unioning the set that contains one element with the union of the set that contains another element. And the end result is a larger set that contains both elements. Look at an example. Here we're going to union the set that contains 2 and the set that contains 7. So the set that contains 2 is going to be this top left set. And the set that contains 7 is going to be the top right set. When we union the set that contains 2 and the set that contains 7, the new set is a single set that contains all of these elements. Now, 7 has a different set identity. Because 7 is in the same set as 2, 5, and 9, we know that the set identity for 7 now must be 2. Mathematically, we can talk about a set as being a collection of different sets. So a disjoint set is going to be a collection of sets where each set has a unique identity in it. As part of this set, we know that each set has a representative member, and that's going to be the element that uniquely identifies that set. And the only operations that we're going to need to program on this data structure is we need to go ahead and make a set out of a single element. We need to find the identity of a given element set. And the final thing is we need to be able to union 2 sets together. We're going to dive into how we create a really, really incredibly efficient algorithm to solve this particular problem all this week. So we'll start by looking at what we can do to build the structure in the very next lecture. I'll see you there.